Okay, here is our second assignment of Unit 6. So these are dealing again with logarithms. Let's remind ourselves what last unit was, or last assignment was about, and then let's go ahead and progress with what we need to learn today. Okay, so if you kind of had to boil down the last assignment into a couple of basic ideas, what we learned is we have exponential form. And that is kind of usually what we're used to seeing. So we have like 5 to the third is equal to 125. So things are written as exponents. Okay, fine and dandy. And then we can turn them into logarithmic. Again, I might be misspelling that. And so the idea of that is the base is the base. So this would be log base 5. Okay, log base 5. And then everything switches sides. So 125 goes left and 3 goes right. And so that is that. Now, second thing that we learned is, well, what if I had to use a calculator to figure this answer out? What if I just didn't know that the answer was 3? All right? What if I needed to figure that out? How could I do it? Well, we learned this a couple different ways. One way is you could rewrite it in exponential form. So I do see that if this is equal to something, this could be equal to x. So I could rewrite it. So base 5 to the x is equal to 125. And then I could say, oh, that's equal to 3. Okay, you could do it that way. Or if you need to use your calculator, all right, we learned how to change base. And again, how you do that is you turn this into a division, cutting off the current base number, and then you put a log with that base. So this is in essence log 125 divided by log 5. And then you can use your calculator to handle those sort of things. So we could go log 125 divide by log 5. And we see that it's 3. And so you could do it that way. Okay, so that's what we learned yesterday. All right, today we are still dealing with exponentials and logarithmic form. But what we are going to be kind of turning this into is we're going to be looking at exponentials that are technically written as this letter E to some sort of power. And we are going to be looking at natural logs, which are just logs, natural logs, but they're written with, it's technically log base 2 point something, 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 something. How it's written is ln. Okay? So the way something might look would be, an exponential would be like e to the 3 or something like that. E to the 3. Okay? Or you would see a natural log as the ln of 5 or something like that. That's how these things are written. Now, what do we need to know to make this what we need to know today? What you kind of really need to know today is that, excuse me, I'm sorry, losing my train of thought, is that these things kind of undo each other, like kind of like a multiplication to division kind of idea. So if I have an e to the 3, okay, is equal to, 4 or something, excuse me, as you were. E to the 3 is equal to x plus 2 or something like that. All right. And I can unwrite this. So like, I know that to cancel out an e, I need to take a natural log of that. So I need to take a natural log of this e, and that undoes the e, and so that releases the exponent to be just straight up a number 3. But whatever you do to one side, you do to the other. And so this would ultimately be equal to the ln of x plus 2. You could do it that way. So ln undoes e, and vice versa. E undoes ln. So if I have like the ln of x is equal to 5, okay? If I have the ln of x is equal to 5, I can put an e onto these things, and that undoes the ln. So x is equal to e to the 5th power. Kind of like that. So ln and e's undo each other. That's kind of like the name of the game. Okay, so write this one in natural log form. So we have an e to the x is equal to 12. Switch this over here a little bit. All right, so what I'm going to do is I'm going to ln both sides. Okay, so the ln undoes e, which releases that x, and x is no longer an exponent, it's just a straight up number. And then ln of 12 is, we just leave it as the ln of 12. So again, here we have e to the x plus 1 is equal to 1. So take the ln of both sides. So that leaves us with x plus 1 is equal to the ln of 1. Write the equation in natural log form. Okay, so again, e to the 3x is equal to negative 7 ln 3x is equal to the ln of negative 7. Okay, write the equation in exponential form. So we have the ln of x is equal to 2. So to get rid of the ln, we need to write this in exponential. So we take both sides to the e power. So that makes x is equal to e to the 2. We can e to its power. So here we have an ln of x minus 1 equal to 3. So e, that gets rid of the ln, which leaves x minus 1, and we have e to the 3rd. Okay, so here we actually want to get these answers, and we can just use our calculator to do that. So 4e to the 2nd power. They do have an E button on your calculator, you'll see. So let's just type this in. So 4e. E is written, hopefully you can see my cursor, is this e to the x. So e to the 2. Okay. Okay, and you could literally type in the letter E as long as you take it to some power for E to, yeah, now that, yeah. So E to the 2. So you could physically type that in. Anyways, let me get this one. 2 decimal places, 2956. So I write 4E to the 2. It's technically what I type in. Negative negative 3e to the negative 3. So again, what I'm going to type in is negative 3e to the negative 3. Oops. Whoa. Evaluate the following using your calculator. So we have the ln of 33. Again, they have an ln button right there on your calculator. All right, so you can just type in the ln of 33, or you can just literally type in the number, the letters ln. You can do the same thing just by straight up typing. 496, so again, rounding 3.4965, et cetera, et cetera, et cetera. Rounding this to 2 decimal places. Okay, the 6 does round, so that's like adding a 1 to the very end there. So if I add a 1, that turns into 50. Air pressure at sea level is 14.7 pounds per square inch as the altitude h in feet above. I'm just going to start. So this is air pressure. As h is the altitude increases, the air pressure decreases. The relationship between air pressure and altitude is modeled by this. Okay. Mount Everest rises to a height of 29,028 feet above sea level. That's an altitude. What is the air pressure at the peak of Everest? All right, so all we're going to do is we're going to type that in for the letter H. So technically what we're going to get is the answer is equal to 14.7 e to the negative 1, 2, 3, 4, 4 times 29,028. That means our pressure is equal to the 10th, that's the first decimal, 4.6, and pressure is measured in pounds per square inch.